Today's video is going to talk about characteristics of graphs and functions. We're going to be starting with x and y-intercept. Now an x-intercept is where your graph is touching the x-axis. It's a point on the x-axis. So a function has an x-intercept if the graph touches the x-axis. And if you think about points on the x-axis, you're either going to go left if it's negative or right if it's positive, but in order to stay on the x-axis, you will not go up or down, and that's because y equals 0. So we know something is an x-intercept if y equals 0, or if we know something is an x-intercept, we know that the y value has to be 0. Again, because you'll only go left or right, you can't move off the x-axis, so no up, no down. Y has to be 0. And similarly, if it's a y-intercept, that means we're going to be on the y-axis, which means x is 0, because I will only go up or down. I will not move left or right at all. Again, a function has a y-intercept if the graph touches the y-axis. And x is going to be 0 in that case. Well, x-intercepts are really important in graphs, so they have some other names. X-intercepts are also called roots, solutions, and zeros. The reason they're called zeros is because the y value is always 0 for x-intercepts. And these are listed as a set of values. So if you're asked for the zeros, then you just give a list of the x values on your x-intercept. The x values that make y 0. That's what they're looking for. All right, let's move on to the next slide. So really important note here, that's why it's starred. Intercepts must always be written as ordered pairs. That's when you write it as parenthesis, number, comma, number, close parentheses, x comma y in parentheses. So in this case, I'm asked to find the x and the y-intercepts. So I'm going to start with my y-intercept. That's where my graph touches the y-axis. And even before I look at this particular graph, I know that because it's a y-intercept, x has to be 0. So I know it's going to be parentheses, 0, comma, some other number. So let's look at the graph. Well, here's my y-intercept. It's at -2. The y value is -2. So the whole thing is 0, -2. Go ahead and make that a little bigger. And consider this your warning if this was a quiz question or a test question, and I asked you what the y-intercept was and you just said -2, you would not get full credit for that question. You have to write your intercepts as ordered pairs. So make sure it looks like this. My x value is 0, the y value is -2. And then for my x-intercepts, well, there are 2 because you can see it touches the x-axis twice. So what are my x-intercepts? Well, the first one here, I'm going to go from left to right, is at -1. So I'm going to write that as parenthesis, -1, comma, 0. Again, if it's an x-intercept, we know y is 0. And the other one is at 3, so x is 3 and y is 0. So 3, comma, 0. Again, make sure we always write those as ordered pairs. Now this is asking me to find the zeros. Now remember from last slide, the zeros are basically the same as your x-intercepts. The only difference is how we write them. So again, zeros are asking you what x value gives you a y value of 0, or in other words, what input makes your output 0. What value is going to give you a 0? And in this case, it's -1 and 3. When we write zeros, we just write x. So we do a curly bracket, and then we write them from least to greatest, -1, comma, 3, and then another curly bracket. Make that a little bit bigger so we can read it. So again, same points, it's talking about the same points, the same values, but we write them differently. Intercepts have to be ordered pairs, zeros are just the x values. Now we're going to define a little bit more vocabulary. The domain of a graph or of a function is the set of input values, input or x values, which is also known as your independent variable. That makes range the set of all output or y values. And this would be the dependent variable. There are two types of graphs, discrete and continuous. A discrete graph is a type of graph consisting of distinct points. If it's continuous, it is a type of graph consisting of connected lines or curves. If it's continuous, that means that we can draw the entire graph without having to pick up or without picking up your pencil. So to look at this graph as an example, if I were to ask you, is this discrete or continuous? I'm saying, is it just a graph of distinct points? Is it just dots on a graph? Or is it connected lines or curves that I could graph without picking up my pencil? Which one do you think it is? This is in fact continuous because I could graph this whole thing by starting up here. It's all connected lines. I could draw that whole graph without picking up my pencil. Next class, we'll talk more about how to give the domain and range of different kinds of graphs.